Lesson 7.4, applications. Now, with percents, there are many applications. We're going to look at 4 or 5 of them, but I don't have the time to do an example of every kind of application there could be for percents, because it would take much too long. So we're going to hit some of the main ones, the ones that you'll be responsible for, not only in this lesson, but on the proficiency. We'll start off with markup. And I mentioned this right at the end of the last lesson, how we could use the new amount types of problems that I was showing you at the end to do markup and discount. We'll start with markup. An increase from wholesale price of an item to retail price. That's what the customer pays. Okay? Company buys it at wholesale, they mark up the price, they sell it to you, they get the profit. Okay, so what we're going to do is we're going to use percent of the wholesale price. I want to show you how to do this now. What is the retail price of a bracelet? That's what you're going to pay. If the markup percent is 50% and the sale price, or the wholesale price in this case, is $12. So what we're going to do is we're going to take a percent of the $12. But what percent? Well, you have to pay the whole $12 and more, 50% more. So you take 100 plus 50, and that's what you're going to be taking the percent of. 150% of $12. So I'm going to slide it 2 places to the left. I'm going to write this as 1.50 or 1.5 times 12, which I can actually do in my head because that one comes out kind of nice, and I get 18. So the retail price, what you're going to pay, the retail price is $18. Now, because it's a story problem, it's an application here, we want to make sure that we put our units down. This had to do with money, and we want to write it out in a short sentence there. Now, similar, only kind of the other way, instead of adding, we're going to be subtracting here, are discount problems. Discount, remember, is a decrease from the original price of an item to the sale price, not the wholesale price necessarily, the sale price that the store puts it at. Calculate a percent of the original price. Going back to the original price. That sounds a little bit like what we were doing in the last section with the original number and percents of changes. In this case, it's a decrease, so we're going to see how much we decrease off the original price. A pair of jeans that originally cost $42 is 25% off. Find the sale price. All right, so we had 100% would be the $42, but we're going to not pay 100%, we're going to subtract 25% off of that. Or we're going to pay 75%. So we're going to take 75% of $42, which would be, slide it 2 places to the left, drop the percent sign, 0.75 times 42. So let's see, 0.75, 42, I'm going to multiply, 0 carry a 1, that's 15, 0 carry a 2, that's 30, 0, 5, 1, 3 with 2 decimal places, so 3150 here. This is going to be 31.50. Now, if it wasn't money, I'd probably just drop the 0, but since it's dollars and cents, I'm going to write 2 decimal places to the right of the decimal point. So the sale price of the jeans is $31.50. Notice again, I put the proper units on here because it was a money problem. Sales tax and tips. Typically, we talk about this when we're looking at a bill from some type of an eatery, a restaurant. And in this case, the bill for your restaurant is $22. You leave a 15% tip, and the sales tax is 6%. What's the total cost of your meal? Well, both the tip and the sales tax are based on the $22. So we're going to pay $22 plus 15% more of the $22 plus 6% more of that $22. So we're paying 100% of the bill plus 15% for the tip plus 6% for the sales tax. That's 121%. So what we're going to do here is our total cost, I'll put C for total cost, is 121% of the $22. So I slide the decimal twice, I get 1.21 times 22, So 1.21 times 22, that's a 2, a 4, and a 2. That's a 2, a 4, and a 2. That's a 2, a 6, a 6, and a 2 with 2 decimal places. And I get 26.62. So the total cost was $26.62 based on this right here. That includes the tax and the tip. Now another important application has to do with simple interest. There's simple interest, there's compound interest. Simple interest is when you make money or you pay money only based on the principal. The principal is either money that you borrowed if you're paying or money that you invested if you're earning. This is your formula right here. Interest equals principal times the rate of interest, which we'll write as a decimal, times the time, and the time is in years. So if they give you something in months, the time in months, you'll have to rewrite it and convert it into years and then plug that in for T for time here. So let's try an example. An $800 bond, okay, so this is a bond, this is more of an investment, right? Earns 2.7% simple interest annually each year. What is the interest earned after 5 years? This is my principal. This is my rate of interest here. I'm going to have to change that into just a decimal without the percent sign, and this is my time here. So my interest earned is 800 times, now I'm going to have to slide it twice, so I'll have to put a little zero there for a placeholder, and I get 0.027 times 5. And I'm going to multiply those three numbers together. That's going to give me my interest. Now I'm going to multiply 800 times 5 first. I'm using the associative property multiplication because 800 times 5 is 4,000, and it's really easy to multiply 4,000 times the number because of all those zeros. I get 0, 0, 0, 28, 0, 0, 0, 8. So that's 0, 0, 0, 8, and then 10 there with 1, 2, 3 decimal places. So this turns out to be 108. So the question says how much interest is earned. They earned $108 in interest. And again, this is a money problem, so my answer is in money. A lot of applications, as you're seeing here, have to do with money. All right, one more. Compound interest. Now, compound interest is interest that's earned or paid on both the principal and any interest that's been previously accumulated. If you get yourself a credit card, for example, the interest is compounded every month. And so it accumulates a lot of interest in a hurry, especially if you owe quite a bit of money. So that's always one of those warning themes that your parents should be talking to you about as far as credit cards are concerned. We're going to really simplify this. We're going to only look at interest that's compounded annually, which means it's compounded each year. And this is the formula. This is the formula that we will use to find not just the interest, but how much overall money is accumulated, whether it's money that we have invested or money that we have borrowed and that we owe. So we're not going to just find the interest, we're going to actually find the entire amount. So here's an example. Oh, by the way, that A stands for the amount. This is still the principal. This is still the rate of interest, which we're going to write as a decimal, and this is your time here in years. You deposit $300 into an account that earns 3% interest compounded annually. Find the balance after 3 years. So what I'm going to have to do here is I'm going to have to plug this in here. I'm going to plug 3% in as a decimal right here, and I'm going to plug 3 years in right here, lots of threes. So the amount, the balance is going to be the principal, 300, times 1 plus 3%, that'd be 0.03. You got to slide it 2 places, drop the percent sign, and that's going to be raised to the third. So this is 300 times, I'm going to add inside the parentheses, 1.03 raised to the third power. Now, unlike many of the other problems that we've done up to this point where I've usually just done the arithmetic either in my head or I've done the arithmetic on the board itself, this time I'm going to get a calculator out and I'm going to figure this out. You'll need a scientific calculator, one that does exponents, so that you're not spending all day doing multiplication with those decimals. So I'm going to take the 1.03, I'm going to raise it to the third power, and then I'm going to multiply that times 300. And if necessary, I'm going to round my answer to the nearest hundredths here. I get 327.8181. There's the hundredths. That tells me I'm going to round up to $327.82. That's the amount of money I'm going to have in this account. The $300 plus, it looks like $27.82 in interest. So find the balance. The balance is $327.82. And again, I've not covered every type of application for percents. One that comes to mind that I've left out has to do with commission. When salespeople make a certain amount of money based on the sales, the amount of sales that they're responsible for. There's numerous other types, but these are some of the main ones, and especially the simple interest and discount, you're going to see those again and again. So remember to practice, practice, practice.